All right, we're live. So, welcome everybody to this talk. What is this talk anyway? This is a talk about fast and maintainable JavaScript TDD. I'm going to show you a working approach that one of the teams here at CJ has developed. It's not the only way to do it, but it's one of them, and it works. I can tell you because I've made it work before.
What's TDD stand for?
That's a good question. All right, glad you asked. So here's the plan. We're going to first define the goals of TDD, and before we even do that, we're going to define what TDD is. And I'm going to show you my approach, and then we're going to evaluate it. I almost said pontificate for number 3, but we'll try to keep it technical and like reasonable. All right. So what is test-driven development? Any takers? Write the test first. Yeah, a lot of people don't even get that. A lot of people think, well, I do tests and I like good code and quality stuff, right? I'm test-driven. That's me. But that's not what I think of when I think of test-driven. Yep. Yeah, it is. It can be fun. It can also be really bad, and I'll get to that. Test first. You said automated tests. Well, I'm just keeping it real high level at this point. Never writing a line of code that isn't directly satisfying a currently failing test. There's a few exceptions, but that's basically the idea. All right. So another way to talk about it is to define it in terms of the flow. What's the TDD flow? Anybody know? Not nobody that works here. Break it, make it. No. Red, green, refactor. So let's talk about that. Red. What's red? You've got a failing test. What's next? No. Green. And that's where you make the test pass. But it might not be the best implementation because that's not really the goal at this point. The goal is just to find the simplest and usually quickest and dirtiest way to get that test to pass. Because you're going to save the beautiful code for the next step, which is refactor. That's where you clean up your implementation, right? You know that it meets the needs, and now you're free to just go to town and make it really nice code. And you know as long as it's still green, you're good. So that's TDD. At least what I mean by it. So I want to lay out, before we get into the way we've been doing TDD JavaScript, what good TDD looks like. Because a lot of people have experience with bad TDD, and I think that's atrocious, and I don't want that. So what's good TDD? Well, good TDD focuses you on understanding and satisfying customer needs. If you're doing your TDD thing and it's really not forcing you to focus on the customer needs, instead you're focusing on some technical workaround to get your test to even run as tests, that's probably not good TDD. I think it's not.
Would you define TDD as being functional tests rather than just unit tests?
I like.
Usually business concerns have nothing to do with unit tests. They're almost always functional tests.
Right. So the question is, am I talking about functional tests, unit tests, because business concerns are usually not unit tests?
Yeah, that's what I'm wondering.
A lot of
functional tests more of a good TDD than just unit tests, or?
So this is where a lot of people might disagree with me, but I don't really care about whether it's unit level test or higher level test, end-to-end test. My end goal is to basically behavior drive the system, and the least brittle test I can get, that's what I'm going to do. That tends to be at the lower level, but my unit is actually a little bigger than most people.
Okay.
So size matters. So another sign of good TDD. This is all live. Is that it produces easy to understand code and tests. If you do your TDD thing and at the end your code is really hard to understand and your tests are hard to understand, not good TDD. Another sign of good TDD is that it results in a complete, reliable, and non-brittle test suite. So if you get to the end of your TDD and you got an incomplete test suite, or you've got an unreliable test suite and it's brittle and it's flaky and it fails every other time, it's probably not doing good TDD. I don't think you are. Finally, it's faster than writing test coverage after the fact. So whatever sort of TDD you're doing, if you get to the end of the TDD and you're like, this was such a pain to do, it would have been better to write the test after the fact and just do the implementation. I would posit that you just had bad TDD, not that it's TDD's fault. And this is the real finally. It encourages refactoring. So if you go through your TDD and you are discouraged from refactoring because you're afraid of breaking a whole bunch of brittle tests, then I think you're doing the wrong kind of TDD. That's not a sign of good TDD. So what's bad TDD? Well, I copied the previous slide and I inverted everything. So it produces hard to understand code and tests, results in an incomplete sometimes, but certainly usually unreliable and brittle test suite. It's slower than writing test coverage after the fact, discourages refactoring. So can it be achieved? It being good TDD. Can good TDD be achieved in JavaScript? And more specifically, in client-side GUI JavaScript. Dun dun dun. All right, so I want to show a little demonstration of this approach. So the way I thought I'd do it is come over here and show you kind of a blank app. So you'll probably have a lot of questions, but save them until after I've shown a little bit, and then we'll get into it. So at this point, I have, what do I have? Well, I'll show you. We're going to write, well, I sat down yesterday, and I thought, well, it would be a good, real, not completely made up app to do some TDD on in JavaScript. You know, that wasn't work specific, so I could share it with you all. And the first thing I thought of was this this app that Sean made. Sean should have been sitting right next to me. It's an app for, I'm going to probably butcher this, but it's an app for facilitating voting using the Shoals method, which is is it Condorcet? Condorcet? Condorcet method, French guy. Long story short, it's this really cool app for voting, and we've got a public instance of it at votecastematic.com. But you know, I think I've got a good enough relationship with Sean to let him know that this UI is not pretty. It's not easy to use. So I'm gonna. Come back. So we're gonna try to make. I thought I'd try my hand at a better UI for a real common use case we have around here, and it's like everybody is ready to vote on something, and they're not setting up of an election. They just want to like whip out their phone and vote on the spot. You know, it's like the TV show where everyone's voting from their seats. So here's my little mock-up of it. Neil Schultz voter UI. So, oh, there'll be. You can get pictures later.
Oh, great. Okay, everybody just hold on.
So here's the thought I had. Okay, there's like a login screen. It's asking the question, who are you? It's got a username field. It's got a login button. That's the login screen. You click login, you're taken to Jan, what do you want to vote screen, which lists all the elections, and you can click on one of them. So let's say you clicked on that one, you come over to this voting screen. And if I understand this voting method right, the way that the thing that makes this special is that instead of saying who you want to be the president, you actually go to all the candidates and you weight them. So you give them a relative weight against the other candidates. Got that right?
Yep.
So I thought, well, a cool UI for that would be you've got these little green bars, and you like click on the minus or the plus to make the green go up and down, and so you've got your relative weights, right? It's kind of visual. And then I forgot to write the draw a vote button, but you click vote, right, and then you get taken to a results screen. So that's the mock-up. So I actually TDD'd just about all this. It took me about 3 hours yesterday and a few minutes just before this meeting. And I don't have time to do that all live, but I can do a little bit of it, and then we'll fast forward to look at the result at the end, and I think you'll get a feel for how the whole thing went. So let's start with the login screen. That's where I started yesterday, and I think that's a good spot. So before I get started coding, what I want to do is set up my fast feedback environment. And the tools I'm most comfortable with are these tools. So I have a script called watch run, and this just watches the file system using ionotify, and when something changes, it runs a command. And I'm using Maven for my build stuff here, so I'm going to run jshint lint and qunit test. Right? So just to show that this works, I'm going to touch, I don't know, settings.xml, right? And you can see it's building and ta-da, yay, get a little feedback there. Next thing I'm going to set up is a way to run the test in the browser. So I'm going to use this root, not server, serve. I'm going to use this QUnit serve goal. And we're going to open this link up in the browser. Okay, so now I can refresh this to see all the 0 tests that I have, which is okay because I don't have any functionality in my app yet. Let's take a look at the app.
You have 100% test coverage.
100%, well, close, right? Right. It's depending on what kind of person you are. So here's the back end part of my app, which is really just a proxy on top of Vote-Cast-O-Matic, because I want to use the Vote-Cast-O-Matic APIs, but I want to re-implement that. So we're going to be live coding against the real Vote-Cast-O-Matic site. And then otherwise, I'm just serving some static content off of the class path here. So here's my class path, and here's my stuff. I've got this index page. It's pulling in this require config, which is kind of a standard require config, shimming in jQuery. And I've got require itself loading, so it's all set up. And just this little stub of JavaScript to get me going here. I've also got some collaborators that I pre-created. This is just one that wraps jQuery Ajax in I think, a better shape. So this is a method where you give it, or a function where you give it a HTTP method and URL, and right now it's just doing a get. And I've got this utility function to do some default value stuff, nothing fancy. But that's all I have, nothing up my sleeve. So let's fire this app up. Whoa, what's that all about? Two errors. Yep, okay, we'll make it. New folder, src main resources. It's because I reset my. Oh, really? Here. Oh, yeah, right. Yeah.
Oh yeah, that's the root cause, because he was doing it live.
Yep. All right, everything's good now. We can run. All right, it's already running somewhere out there. Oh, there it is in the background. So it's just a little main method. Here we've got our server. All right, so it's there, but there's just nothing showing up. You know, we could put something like welcome, and it'd show up. But we don't need that right now. So let's start talking about our login screen. I think that's where we should start, but we really got to start with our test, right? That's what this whole thing's about, test first development. So let's start with a test. Let's call this login screen.qunit.js. So .qunit.js, that's the filter, the pattern that this plugin matches. Come on, Eclipse, figure it out. There we go. Wait. Oh boy. Oh yeah, I don't have anything in there. So how do we make this? Well, we're going to start with a require module. There's no collaborators yet, no dependencies. Okay. So this should be enough to get our test showing up here. But there's no tests here. I guess the issue, probably have to restart that the first time. There we go. Okay, but it's going to be a failing test. No, it's not. No, it is on the class path because, or on the command line because it's expecting at least one test, I think. I don't know. We'll get our feedback in a second. What's our first test? Just thinking out loud here. Let's just start simple, just to get our feet wet. So, you know, has a let's describe the behavior, the characteristics that we want. We want it to have a login, a text box for the username, right? Sounds good. So I like to do given when then when I think through my test. So what are we going to have here? We're going to have some spot in the DOM. I like to call it view. Maybe it's not the best name, but so this is a little anonymous div. Starting to depend on jQuery. jQuery. And we'll just use the $sign. All right, so we got a DOM, and we're going to have something. Let's call it login screen. This function that takes that view, and then, well, that's our when, right? We're making the login screen. And then my then is there should be a text box, right? So view dot find, keep it real generic. Find an input, right? And then my assertion is that there should be one input, right? Real simple. Except there's no login screen, so it's not gonna pass. Like, what is that? Login screen is not defined. Well, if you really do TDD, you don't even break stuff out until it has a reason to be outside of your test. So I'm going to make a login screen right here. Here it is. It's got a function. So we have a different error there. We expected a input, and we don't have it. So let's make it. So we've got this view. We didn't call it DOM here. Right? Let's call it my DOM. This is the DOM part that's just for the login screen. So what's the easiest way to make this test pass? Let's just, I'll cheat a little bit. That's probably fine. Does that work? Maybe that'll work. Yeah, I'm going to fix that. All right, let's see if that works. Yay, so I got an input box. So one thing I like to do when I'm doing this sort of thing, hey look, I'm successful now. You don't see these hidden divs, so just on the test when I'm messing with it, I'll do something really horrible and use a global variable. You see the global variable there? It's right here. This is a global selector. It's not relative to some specific spot. So it's a big no-no for me, but I'll do it just as a hack so I can see what I'm doing. So there it is. Look, got a text box. All right, what's the next thing we want? How about a text box for the username and a login button? Sounds good. Just tack on another thing here. How about we say that it should have a button, just a regular old button. But it's going to be a button. We should have one of those. All right. So that failed. It's pretty easy. And I kind of cheated there. I could test the text there as well, but I'll keep it really loose. I'm gonna wrap it in a div. All right, so we got a login button. What should happen when you click the login button? Well, I'm going to wire this up as a component in a broader component tree. So I don't really want to make it the responsibility of this login screen to do the HTTP calls. So I'm going to delegate this to something else. And for that, I'm going to make a new test. All right. I think we've reached our limit with that test. So invokes on login callback when the user logs in. So should have our test there. Hey, we need at least one assertion. So a lot of this is going to be similar, right? Given a login screen where someone enters a name and presses login. So really it's the presses login that we're going to be testing here in our when. Given when someone presses the login button, then what's our expectation? You know, the on login callback should have been called. So let's get this figured out one bit at a time here. Here's a view. I'm going to need that. We're going to need our login screen. Right? We're going to need to enter some text. So what should our text be? Freddy. And then we're going to press the login button. So there's our login button. All right, so far so good. Now this on login callback, that's interesting. Let's say callback looks like this. It's just some function. And we pass it in here, and this will be our contract with the login screen. And we're going to need to know whether it was called, so simplest way to do that is to do something like this. All right, now we know whether it was called. All right, that should be false because it's not being called yet. And I used the wrong equals. For some reason, they want you to call equal in QUnit these days. All right, so red, let's get our green. So we'll go over here, and what are we going to do? We need to have some behavior on the button. So I'm going to pull this out as a variable called parts. I'm going to have it appended to the DOM. Here's my button, and here's what it's going to do on a click. It's going to invoke that function. Right? Where's the function? Here it is. Cool. Oops. Try that again. So that's not working there because we don't have a function being passed in on the other test. In fact, we should probably move this little sheet down here to this test, then it will work. So, I mean, that's cool, but the problem is if somebody wants to know who logged in, that's not going to work because we don't know who logged in. So let's change this. User who logged in. All right, that's what we really want to know. Who logged in? And the user who logged in is going to be whatever's passed in the callback, because I want to know this. I could have updated the name here, but not going to go there today. So what should the user be? Anybody? Should be Freddy, right? User's not defined. It's interesting. 46. Wrong variable. Okay, should be Freddy. It's nothing. Let's fix it. So now we know that our callback's getting Freddy. So at this point is where I'm thinking, you know, I'm not focused on the look and feel right now. The login screen works good enough. So now I'm going to start wiring it into the rest of the app. So I would make the upper level component and start wiring it in there. So I'm not going to bore you with all that at this point. I think you've seen enough to get a feel for the flow. I've got continuous feedback from the command line. I can run the test in the browser here. I can even see it and play with it while I'm messing with it. The test names are kind of saying what it's doing, and I'm driving the behavior as I go along. The code I'm writing is fine. It's really simple at this point. There's not a lot going on. It's a pretty trivial screen. There's some duplication here I haven't factored out yet because I just trying to speed through this. But we've got some pretty decent tests here. I feel like I could go in and mess around with all the parts here. And if my tests were green, I think at least this particular component was still going to work. So let's cheat. I'm going to cheat. Is it -v? Right. Checkout complete. All right. Okay, so here's how we fast forward into the future. Again, this was about 3 hours later, and here's what my tests look like. So you can see this was my original login screen. I actually only had one test in this case. I just had it all. Sometimes you'll do this, like when you get into testing something, the real trivial stuff you start out with just to get the ball rolling, you'll delete it later because it doesn't have a lot of value. In this case, the real value is there, just the callback that sent the right user. So there's my login screen test. If you look at my app, my first test, which this would have been the next one I was going to write, is a test to see that it shows the login screen by default. What's my app? My app is kind of my main method. It's the thing that I'm invoking from the top of my application. And I know his implementation is not terribly interesting at this point. So I have a test to make sure that he shows the login screen when the app first starts. And then I realize I need an election screen. So then I go ahead and make an election screen. So you'll see tests like this. This test, the election screen should list the elections in the system. So here's the when I create an election screen and with a view and a fake HTTP. So this is noteworthy. Since I've abstracted myself slightly away from jQuery Ajax, it's pretty easy for me to mock out HTTP to fake it out. So that's what I've done here. Here's a fake HTTP that will respond nicely to a get for elections, and it will return this list. So when there's elections out there like this, and you make an election screen with a fake like that, then there should be 2 entries on the screen that have election entry buttons. And the first one should be foo. Why? Because that's the first election on the system. And then I've got to test it to make sure that when you click on an election, it'll take you to the next screen. Again, this is a callback. Should be anyway. Yep, here's the onSelect callback. And the testing here that the onSelect callback calls back with the right election name. So really simple little component. The election screen is pretty simple. And the components are wired up in a similar way. I've got, going forward, I've got a voting screen where I'm making sure that all the candidates show up. So again, I'm mocking out some HTTP that's simulating a server with these candidates. And when I'm showing the ballot for user Andrew and election foo and this fake HTTP and this collaborator mocked out, I'll explain that in a minute, then you should see all the options on the screen. So this collaborator here, what I decided to do is, I mean, this is really simple. This is one component. This guy is really simple, one component. This guy is a little more complicated. So what I decided to do was break each one of these rows out into its own little widget. But when I was TDDing the big part, and I did that first, I didn't want to have to deal with this little component guy. So I mocked him out. I faked him out. And eventually I went ahead and made a real implementation for that. So hopefully you get a little feel for how this goes. I'm going to restart the app and just show you the whole thing working, and then we'll get into some analysis. So let's see, localhost. So here I can say my name is Stu, I can choose an election. Choose an election. Let's see. Galactic Emperor, sure. Now I've already voted on this one, but you can vote again. It's sort of an upsert. And let's see what my current vote is for the guy in here, and just kind of demonstrate that it works. So right now I'm liking Zool the most, followed by that, however you say it.
Yeah, it's reversed. Number one's your first place vote.
Oh, psych. I'll have to fix my test because I coded it the other way around.
It says so right in the documentation.
That seems, nobody reads documentation. Certainly not me. All right. So now I need to go like inverse weight. So I don't like this guy so much anymore. Who did I like before? I thought 3 meant I liked him. So let's bring Darth Vader up. Dana up a little bit. This guy up too. So Zool should be like in the bottom now.
Hello?
That work? Yeah, that should work, right? Zool should be to the bottom.
The hard part of that UI is it's mainly
Yeah, I know.
it's a UX design flaw.
It's an issue. Right. Yeah. Anyway, pretend that it works.
Still,
With-
feel like we know you well enough to say that the UI problem.
Yeah. 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 Thanks. I appreciate the honest feedback.
My last time here.
Yeah.
It's been great.
Is there the eject button in here somewhere? No, you're totally true. All right, that's totally true. What I was hoping to do at the end was have some time to make a nice style sheet for it, so I could like, as a last final trick, apply the style sheet and show you how all the tests still pass without changing anything. But I didn't get to that. But you could pretend like that happened. Then you might have a different opinion. That's one thing I won't test, right? Because it's usually very, very difficult. If you can't easily reduce it into text, it's just not practical.
When you're testing GUI, it's all about alignment and everything's defined in the style. You have to make sure it came out as perfectly possible for
You already said he was.
Yeah. So it's a
Actually, article said as exists that they can tell you that something is wrong.
Yeah.
But the tools that can tell you that the layout changed so that a human can go and look like, okay, this change is good, and then
right.
versus going, oh, okay, someone actually wrote it. And I think
Yep.
it was Facebook was using one of these tools and discovered that one of the pixels became like 0 pixels high, and their tool caught that, humans did not.
Yeah, we're experimenting with something similar. There's a tool called perceptual diff, and it can tell you, given an image that shows you what the pristine thing, what you want it to look like, and then compare it with some other image that you take as a snapshot from like, some browser scraper. Right. Right. Yeah.
Every test of actually checking the HTML solve in this case saw the actual image tags. They were there. They just had size of 0. So one tool didn't catch it, but the other one did.
Yeah.
But yeah, I guess my question is more about if it's test driven, how do we test drive?
Yeah, the question is how can you test drive the visual part? We have taken the approach it's either not doable or certainly we don't know how to do it and it hasn't been worth it for us. So we have our designer people give us either do it themselves or we'll come in and apply their style sheets to things. And then that'll be the gold standard. And where we'd like to be, that's why we're experimenting with the approach you mentioned, is just be taking pictures of this stuff, and then you could have like a visual regression. But it's not TDD. It's regression testing, automated regression testing. But that's the stuff that you just need a human being. Computers aren't good at that. To look at it, to at least set the what it should look like. Now that's not to say you couldn't have a designer get into TDD, but it probably wouldn't be very efficient. They'd have to come up with test-driven design. They'd come up with like, well, your test would be a Photoshop file or something, right? And then, then you keep changing it till it looks exactly.
But, I mean,
It could work.
It's
It actually could work.
Like in this one, you could have all the negative signs or the plus signs lined up.
Right. Depending on how you do it, yeah.
Well, it's relevant that you can ask the question, does this image look exactly like this? But it's really hard to ask the question, does this GUI look aesthetically pleasing?
Is this how it should be?
That's yeah.
And
Right.
that's what you really care about, right? So the thing you really care about is vague, not you don't really care about the pixel perfect thing. You care, does it look?
Well, designer
And also
designer
people-
cares
people
about that.
give opinions. It's-
Yeah.
you can't really define-
You can define your opinion. It's just so you could TDD this. You could with something like the perceptual dip. You could come up with a pixel perfect image. And you say that's my failing test. The perceptual difference is bigger than 0 between that and what it's actually doing, and keep hacking it until the difference is 0. You could do it.
Yeah, I was about to say, that sounds like a nightmare for cross browser. And it's never pixel perfect from browser to browser.
You could just pick a browser and say that's your reference one. But yeah, I mean, I think that's the part where the returns are diminishing so much that, you know, that's
But ultimately, the goal is the same. You have a very well defined upfront
Yeah.
layout, and you're going to look to validate was it done that way or not.
Yeah.
And as you code it, validate every step to make sure it's a good definition. Defined well enough, it doesn't become prefix every single statement like test 4.
it would be interesting to sit down with a designer and or somebody who's doing the style sheets and try that with them. Just say, yeah, you want it to look like this? Okay, put that image in there. Let's hack it till it looks right.
Well, I guess it also depends on how you're taking your design, which is embedded for aesthetics and usability and functionality that you're desiring, and taking it over to the implementation phase, which what you're describing here is testing implementation. You know, it's not testing customer experience.
This is for functional reference.
Yeah.
Assuming the function's been designed properly.
Well, but the other, I mean, the biggest benefit that I've seen in test-driven environments is that you bring in, say, a new developer, and basically you give them a dev environment, and you can say, that's wrong. Because when you change
Yeah.
something, you're going to see it break, right? And that's,
Yeah.
you're going to learn the system so much faster. It's going to make a whole lot more sense. You're going to see the pieces work together. You don't get that, even if you had tests that were telling you how your UI would work. Somebody, they either know CSS or not, right? You don't, that's a predefined ecosystem that already you either know it or you don't know it. And so you're just running out bugs in what you put in when you UI changes. People see it when you UI changes. It either varies enough that it matters and people will notice it, or it varies so little that it doesn't actually affect the user experience. And your designer is going to tell you that. You know, the test should help you find things that you wouldn't normally see. If I mess up an overwrite page to a blank screen, everyone's going to tell me I did that. But if I mess up and carry a 0 in the wrong space and all the numbers that have been calculated from this form for the last month have been wrong, someone might not catch it right away. That's
Yeah.
where the tests are good.
Yeah. I mean, up until now, we've relied on catching visual regressions through what we call like a manual smoke test. So right before deploying, somebody will go in and look at all the tabs and kind of eyeball it and make sure it's not ugly or horribly missing something important. You know, like the functional test could all be working, but the thing is set visible false or whatever. Not visible, so you don't see it.
We found we had a layout problem once where stuff was just shifted down where it shouldn't have been, and we did catch it. So.
Yeah.
There's another problem too with the visual checking, and that is it also depends on so typically you have to have some sort of built-in data set when you test it that way.
Yeah.
Because depending on the content you actually have on the screen, things can move around.
Let me.
Go down into the world of probabilities where you don't look at 100% accuracy because the word might have changed. Instead, you
Yeah.
have some probabilistic threshold.
This is a good topic, but I do have some more stuff, so let me get my stuff out and then
I
I'll.
just wanted to add a few
Yeah.
things to the test that you actually had. So when it comes to TDD, I saw you were using different one then, and I like that syntax too. Writing tests that read like English are very helpful because when other people read an actual test, they can read through and go like, oh, that's how it's supposed to work. And when you get that, it actually also describes the code. So if they haven't worked on a project before, you can then go to the test first and go like, oh, that's how it's supposed to function. That's how the original programmer, when he wrote the test, expected it to work.
Yep.
Because that you can typically not deduce from the code, right? Or it's a piece of art.
Right. Yeah. A sign of mature tests that are a mature code base has been TDD'd is you're going to want to go to those tests first because those to understand the system because they really do document the requirements of the system.
Yeah. And the other thing too is that if you find that your tests are getting really, really complicated, you simply signal that you should refactor.
Yeah. So I've got some of that in here. Let me get to this. I'm going to briefly describe the approach I took here and kind of call out its strengths and how it relates to the goals of TDD. So the first part of the approach I want to call out is that this is component-oriented design first and foremost. So what's that? Well, component here, I mean visual components. So given that this is a GUI, I'm focusing on encapsulation of visual components above pretty much all else. That's my number one principle. So what does that mean? Well, why? First off, that's really how the customer thinks of the app, right? When a person uses your app, they're not thinking about code. They're looking at things on the page. They're seeing buttons. They're seeing sections. They're seeing rows. They're seeing lists. They're seeing tables. So if you structure your code around that, that's probably a better way to go, which brings up the notion of domain-driven design. And I think it applies to UIs too. The notion being that the structure of your code should reflect the domain of your customer. Because to the extent that that's true, it's going to be flexible when the requirements from your customer changes. Because they're more likely to say, well, that button should move over here, than they're obviously not going to say your callback for XYZ should be doing something else, right? So if your code is aligned around buttons and things that they see, it'll be better. Another note here is that some people might ask, where's the model view controller? Well, you don't see it because, I mean, those responsibilities are there, but I'm really not focused on that. I'm focused on visual components. So they're there, those responsibilities are there, but they're an implementation detail of each component. And these ones are so simple, I don't need like an MVC framework to build anything out. But you could pull out pieces, but the point is the model and the view controller together compose the component, or define the component. Other thing I wanted to mention was that there's a very simple interaction between components. There's not a lot going on there. Maybe a callback or two, and then just some composition within the DOM. If the interaction becomes complex, it's a sign that your code is poorly factored, exactly what you were talking about. And so the solution is to refactor, either breaking it apart or combining it, whichever is the right approach. So it helps you get some better code there.
Can I ask a question really quick? What do you think is the correct way to include components? Like what sort of things should they be doing?
I've got something on that in the advanced section at the end of my talk. We'll get there. The approach, another part of the approach is handling state. All right, so the first thing I want to note is that components encapsulate state. So what kind of state? Well, there's the DOM state, right? The DOM's a big mutable ball of mess. And each section of the DOM is only touched by one component. So, even like the smallest component, its parent can't, or according to this design philosophy, can't touch the DOM of the parts that are inside of it, like the subcomponents. Right? That keeps things simpler because although you still have that mutable state, it's owned by one very small and very specific bit of code. That's the component that renders it. Second, JavaScript variables are scoped to the component. So if you have any need for them, they're not shared inappropriately. There's really little to no mutable state shared between components. Very minimal state. And the components themselves have very little mutable state, usually because they're so small and they're doing so little. And also, there's no globals. So you didn't see it in this thing, but one of the things I'm really big on is using static analysis tools, particularly JS Hint, to just make sure I'm not inadvertently depending on globals. I think globals are evil, and JS Hint helps me catch them. Another aspect to this approach is the stability of the design. What do I mean there? Well, first, there's few dependencies needed. I didn't really need any significant dependencies so far, although this was a small app. I do need a way to access the DOM and generate events. I could roll that myself, or I could use something like jQuery, which I did. You need a way to run tests. So QUnit works fine. We use it. There's lots of others. Doesn't really matter what you choose. But this approach favors basic language features and well-written code over, what was that thing you were talking about earlier? MVC whatever. Right? So if I had to choose between using some particular MVC framework or having good basic code that's well written, I would choose the basic code that's well written. And that's kind of, you see that in this approach. And I think the result is that you've got code that should be maintainable by any JavaScript developer, even many years down the road, right? Even when the MVC framework de jour is no longer de jour. So one other aspect of the approach is the smooth workflow. There's little to no friction with tools. The tests are easy to start and refactor, so all that stuff's kind of taken out of my way. And I have this instant feedback loop. And this is not complicated, by the way. This is this little script right here, little wrapper around IO notify wait. So we're not talking about crazy complicated stuff. Get back into full screen. Yeah, crazy simple. And another aspect of the approach is that there's focused tests. So each test is focused on a single function, and it's composed of a given, which is the input, a when, that's where you invoke the function, and a then. Sometimes you'll see tests that are really complicated and they've got these chains of given when then, blah, blah, blah. Or it's really hard to find out what you're actually testing. Like, where's the when? Where's the one function I'm testing here? But you'll notice all my stuff is very strictly called out with a when, and then everything else is either the input or the output. And one thing of note is that with visual components, those three parts, the input, the invocation, and the output, is often indirect. It could be via input events, so it's not like an argument to a function directly. It could be via side effects in the DOM. That could be the output. So another bit here that's notable is this is all black box BDD testing. So behavior-driven and black box testing. Tests specify behavior, so they tend to not break unless the requirements change. That's an attribute of both of those two qualities, or a reflection of those two qualities. Tests setup and expectations are abstract. Clicks and text on screen are examples of that setup and the expectations. So they tend to survive style appearance changes. Like, I don't have a lot of hard-coded notions of exactly what it looks like on the screen, kind of to your point earlier for this functional testing. I'm just making sure there's somewhere on the screen this particular text. Or you saw I wasn't really particular about what kind of input it was. As long as the input had a value, that was what I was expecting from the user. That worked for me. So keeping your interaction in terms of the DOM, since that's how your user is going to interact.
So I had a comment on that.
Sure.
If you start doing things like that, you can end up with a lot of brittle tests. So the
Yeah.
smallest little changes will constantly break your test.
Right. Yeah. Yeah. It keeps it non-brittle. So inputs are generally user actions and an initial state. You've got these outputs that usually changes to screens or maybe event callbacks, sometimes accessors. And finally, the result of all this, like we've been talking about, components can usually be completely redesigned without breaking tests. And I think that's really the key. You know, if you re-implement the component with some other framework, but the tests still work because they were just testing what you really cared about, that's exactly where you want to be. And this usually gets you there or really close. So for example, if you change MVC libraries, change DOM tools to something other than jQuery, what if you change an HTTP tool? So I think this is my last one. Deterministic tests. So these tests are deterministic. How? Well, async calls are faked out. Stuff like HTTP, third-party async stuff, it's faked out. And there's more complicated, more fancy ways to do this with promises and stuff like that. I just kept with very simple stuff this time. And also, tests tend to focus on smaller parts of larger workflows. One of the things that makes tests non-deterministic and flaky is when you're just testing, a big complicated workflow. But if you break the workflows down into just small interactions with small components, they tend to be more deterministic. So you avoid those kind of race conditions, and you make it a lot easier to stub out the outside world. If you're doing an end-to-end test, like we're talking about with the visual testing, you have to stub out or otherwise very deterministically set up a whole bunch of tests, unless you can somehow use a fuzziness metric to gauge success.
Question about your async calls faked out. When you fake those out, do you fake out the asynchronous nature of them so they run synchronously, or do you simulate when they return?
In this case, I fake them out completely. So I have an alternate implementation. I don't know if that answers your question.
Oh, so do they come back? Because in the real code they happen asynchronously. So
actually, so that's something I didn't put on my slides. This is one of the more controversial things. This one out. But I will, and people will hate me for this. I will not do async by default, even with my real code, my production code. And there's a reason behind that. It's because being async actually introduces a lot of complexity. And usually there's not a good reason for the complexity, because usually your app has to work fast anyway. If it usually async is a way to, supposedly it's sold as a way for HTTP calls, it's a way to get responsive UI, right? Maybe that's the wrong word, but it responds to your input quickly, right? But that's really going to be a function of how fast your server is. So I would.
I'm with you there. I'm just talking about when you have to be async to get an Ajax call.
You don't have to be. I'm not.
Okay.
For example, jQuery Ajax has an async option that you can pass the false attribute to. So if you really have a slow server, which is what async solves, or maybe a slow connection, you're really designing around a slow connection, then I would argue that for good UI purposes, you need to have like a busy progress indicator. And if you're not doing that, then I'd say your UI is not all that much the better for having async operations, because your user clicks, but they don't get any feedback that something's happening. So, yeah, you're not blocking the UI thread, but I don't know whether something's happening.
More about that later.
Except in case there's UI thread maybe have shown something else going on at the same time, if you block that, then it appears that everything is stopped.
Sounds like a light to talk to me.
Yeah, no, that'd be a good one. Oh, that was my machine actually going to sleep, I think.
We're no longer
You were so boring. You put your computer to sleep.
It's a new world record. All right, I got 5 minutes here. I'll pull up the rest of my slides on my phone.
Let's do it right
All right, so what's my next slide? That was the end of that stuff on approach. So next question I was asking is, can it really work on real apps? Because this is not a really nice app. And yeah, we have an example, appleeducationaffiliate.com. It's a site that we made for Apple. It's made the administration UI, which is I think a decent UI. Multiple tabs, multiple configuration things, everything you need to administer a whole affiliate advertising program is all made using this approach. So it can actually work for real apps. And so it brings us to the advanced topics if we have time. So testing intercomponent contracts. That's one of the advanced topics, right? You don't see any of that here. So that's one of the brittle parts of what I wrote. So I could have this fake, and it is mocking out, it's faking out the real thing in a certain way. But then I could change the real thing. But my tests might not fail in the right way, because I might not have gone in and updated the fake to work exactly like the real thing. So that's a problem, right? What can you do to work around that? The problem of the stubs getting out of sync with the real component. Well, it's a little bit less of an issue than you might think, given how simple the contracts tend to be. That's one observation, but it is still an issue. So there's a couple ways to solve this that I know of. One is with a happy path integration end-to-end smoke test, right? And you could do two ways. You could do that manually, and we've done that a lot. So, just somebody go around and clicking around all the tabs. If things are wired up improperly, and your tests are saying green, but your real thing's probably not going to be working at all if it's not wired up properly. So it's a cheap way to find out whether your contracts are not working. Or you could do an automated happy path smoke test. That's just a little bit more work. Slightly better, I would say, is implicit contract validation, which you can do with something like Squire. If anyone's used that, I know people here at CJ have, but the idea is it's this tool. You can say make me a fake for this guy over here, where you pass it a real instance of something. And if you fake out something that's not in the real instance, or that works a little bit differently than the real instance, a lot of the times it'll catch that, and your test will fail. It says, hey, you're faking this out wrong, right? So that's a way to get the contract right there and failing when it should. And I think the best approach is implicit contract validation or explicit contract validation. And you can get that with things like Google's Closure Compiler, something that gives you some types on top of JavaScript. We've also got this thing that I've shown here before called Protocop, which is a kind of experiment, but it's another way to have a contract between two components. You can make sure that a formal contract. You can make sure that your stubs use it. So the other advanced topic is functional programming, and so here's the problem. In what I showed you, there's mutable state, and mutable state is bad. The approach that we took here mitigates it well, but it's still there. So what can you do? Well, one solution is to adopt a pure functional approach like React. So what this will do is it'll let you treat the DOM at least as immutable, and the the state within the function scope of your components can be dealt with in an immutable way as well. That's it's not completely immutable around the edges, right? Because you still need to eventually mutate the DOM. But if you take the approach outlined here, you should be able to, most of the time, bolt in something like React on the inside and still have the tests be pretty much unchanged, if not completely unchanged, because you're just swapping out the implementation. As long as you treat your mutable boundaries as the edges of your component boundaries, then that'll work. Anyway, that brings me to the end of my presentation. Any questions?
I wanted to bring up.
Yeah, I think so.
I wanted to bring up, I noticed something you kind of glossed over, but I kind of wanted to draw attention to it, was that when you were doing the red state, you actually